Hello and welcome back. I always noticed some of my students get confused between the various terms used in process analysis. For example, cycle time, flow time, lead time, flow rate, average inventory, etc. etc. So, in this video, I promise you to clear these confusions once and for all. Let's consider a small pasta shop which sells pasta during lunchtime. Let's call it Awesome Pasta Bistro. During lunchtime, customer come and queue up. The pasta making has 3 steps. The first step is where customer places the order. There is one worker who takes the order and prepares the ingredients for that order. It takes 2 minutes to do this. The second process step is the cooking of the pasta. There is one worker who does this cooking and it takes 6 minutes to cook. The third process step is to serve the delicious cooked pasta on a nice plate and serve it to the customer who's waiting. There is one worker here who does this. Incidentally, he also collects the money. It takes 2 minutes to get all this done at this process step C. During lunchtime, customers come and queue up. Let's assume each customer order just 1 plate of pasta to keep our case simple. Customer 1 comes. There is no one in the queue. So he places the order at time equals 0. His order gets prepared at the process step A and gets finished at time equals 2 minutes and leaves the process step A and enters this next process step, which is cooking, at time equals 2 minutes. Of course, it gets cooked there for about 6 minutes and it leaves the process step B at time equals 8 minutes. It then goes on to process step C and enters the process step C at time equals 8 minutes and leaves at 10 minutes because it's only 2 minutes at process step C. So customer 1 gets his pasta at time equals 10 minutes. So he basically spent 10 minutes waiting to get his food. Customer 2 comes in and places the order, but his order can only enter process step A at time equals 2 because the process step A is busy with customer 1's order. The second customer's order can only enter the process step A at 2 minutes and it leaves at time equal to 4 minutes. Similarly, customer 2's order can only enter the process step B at time equals 8 minutes because process step B is busy with customer 1's order. So it can only enter at time equals to 8 minutes and customer 2's order comes out of that process at 14 minutes. It then goes on to process step C at time equals 14 minutes. Since process step C is available, it's not busy, and it leaves at time equals 16 minutes. So you can see now how this works. Finally, customer 2 gets his plate of pasta at time equals 16 minutes. You can now see how this whole thing works. So let's talk about cycle time. Cycle time is defined as the time that passed between customer 1 getting his pasta and customer 2 getting his pasta. We know that customer 1 got his pasta at time equals to 10 and customer 2 got his pasta at time equal to 16. Therefore, the time elapsed between these two events is actually 6 minutes. So this is the cycle time of this process. You can apply the same logic between customer 2 and customer 3 to find the cycle time. Let me fill up customer 3's data here. He comes in and he follows the system, and he will get his pasta at time equals 22 minutes. Okay, now let's talk about flow time. In this process, we see that flow units are the customers. All customers arrive at the same time at time equal to 0. C1 gets his plate of pasta at time equal to 10. Therefore, his flow time is 10 minutes. Customer 2 gets his pasta at time equal to 16. Therefore, his flow time is 16 minutes. Customer 3 gets his pasta at time equals 22 minutes. So his flow time is 22 minutes. You can see the flow time is different for different flow units. If you are lucky enough to come early, you will get your pasta early. So your flow time will be less. Let's extend the spreadsheet up to customer number 10. You can see I have done the same, I've applied the same logic all the way through customer 10, and I have calculated the flow time. I've also added another column L, which captures the actual waiting time of the customer before their order gets processed. For example, customer number 1, waiting time is 0 because when he comes in, there was nobody in the queue, so his order goes right through the system, and then exactly at 10 minutes he gets his pasta. His waiting time is 0, his order was processed straight through. But it's not the case with the rest of the customer. Look at the customer number 10. He gets his pasta at time equals 64 minutes, and he has to wait 54 minutes before his order is processed. Let me also take you through some of the metrics of this current process system here. First, cycle time, which is 6. We all know that. Secondly, if you look at column K, we know the individual flow time of the customers. So I take an average of all the 10 customers, and that's what you get, 37 minutes. So the flow rate per minute is the reciprocal of this, 1 divided by 37. So that's your flow rate. If you recall, the flow rate can also be computed as 1 over the cycle time. So the cycle time here is 6. So 1 over 6 will also give you the same flow rate per minute. Average waiting time. I take an average of this entire column of 10 customers, then that's the average waiting time customers have to wait. For a lunchtime, this is not really a very good situation. People only get half an hour to 45 minutes for lunch. If on average, if they have to wait 27 minutes, that's not really good. And if you look at the customer 10, poor guy, he got to wait for almost like 54 minutes before his order is processed. And by the time he gets his order, it's 64 minutes. The flow time is too high. So now how do we improve this process? First of all, let's look at the process steps A, B, and C. So you know that you can see process step B is slow. That is the bottleneck here. So incidentally, the bottleneck in a multi-step process will dictate the cycle time. You can see the processing time at the bottleneck process B is 6 minutes, and that is the cycle time. But how do we improve? How do we make the system faster? So we remove the bottleneck. Let's add one more resource here. We put one more worker or a chef with one more wok. Enter. Everything improves. Now you can see the cycle time has improved. From 6, it went down to 3. So it's 100% improvement. And the average flow time has gone down from 37 to 20.5. Flow rate has doubled from 0.16 to 0.33. From 10 to 20 based on 1 hour. And the average waiting time also has dropped from 27 to 13.5. Is this an ideal situation? If you ask me, I wouldn't say this is the ideal situation, because for lunchtime, if you look at the customer number 10, if he has to wait for 37 minutes, that's quite a lot of waiting. There is some improvement you still can make. What if we balance the process steps? We try and balance all three process steps by adding one more resource here. Enter. So now it looks much better. You can see cycle time has gone down to 2 minutes. The flow rate has gone up to 30 customers per hour, and the average waiting time has come down to 9 minutes. This is not bad. This is acceptable. If you want to further improve, then you may have to consider doubling all three processes and prepare one more production line here. That would be the next step for improvement. Okay. Let me also touch upon Little Slaw. Since we already know the flow rate and also the average flow time, you know by Little Slaw. If you have these two parameters, you can find the inventory. In this case, the number of customers waiting at any point in time in this system. On average, the inventory is 7.5 now. Originally was 6. You might think, how come the inventory has gone up? Isn't it bad? You have to look at this inventory in the context of flow rate and the average waiting time. Last time, yes, the inventory was only 6, and this average inventory has got an average waiting time of 27 minutes. But look at this, now it's slightly gone up, 7.5, but the average waiting time has gone down to 9 minutes. So people are served faster. They don't have to wait. So that's the intuition here. The bistro can only handle 10 customers per hour, and this time now they can handle 30, which is more reasonable. And with so much customers passing through, the average inventory is still quite close to the original. This situation is acceptable for this pasta shop. They will make money and customers will come back. But in case 1, I doubt I will ever go back if I was customer number 10. I hope this video clears the confusion between cycle time, flow time, average waiting time, etc. Thank you and good luck.